Hi everyone. Welcome to the Duck Stage 1, and we are in the Devworld 2025. So for my presentation, my topic is AI, embedded system, and robotics. So I'm from the Robotics in China. My name is Chen, and I'll start my presentation from now. The first thing I want to talk about is AI in computer vision. I believe computer vision is the most widely used thing for applications. So AI in computer vision and object detection. So we all know that AI stands for artificial intelligence. So artificial intelligence actually has revolutionized the computer vision by enabling machine to interpret and understand visual information. And there are a lot of different tasks in the computer vision. And for example, we have, say, image classification, object detection, and instance segmentation. And they are very useful in different situations. So for example, like in object detection, if you want to, let's say in a street, you want to detect like different cars, like how many cars right now in the street, you can use a USB camera or whatever kind of camera, and then you use that camera to take pictures, and then you send those pictures to deep neural networks, and then the deep neural networks will tell you, okay, how many cars are there in the street right now. So yeah, that's one of the application for object detection. So yeah, that can be very useful. And also, if you want to detect, like, say, a bicycle or a pedestrian in the street, yeah, that can be very useful too. So for those tasks, they are powered by deep learning techniques. So especially for like deep convolutional neural networks, and the abbreviation, I believe, is like CNNs. So the CNNs can extract the features from images, and therefore they can produce some highly accurate predictions. So specifically in object detection, today I want to talk about YOLO. YOLO stands for You Only Look Once. Yeah, that's the full name of YOLO. And it's originally was like a paper published by a I would say like a group of experts. Yeah, they are into computer vision for many years. And YOLO is like the one-stage model. So originally there was like a two-stage model, and the two-stage model was not very efficient. Actually, yeah, it was very inefficient, actually. But yeah, YOLO improved the architecture of the neural networks and make this network in just like everything in one stage, like where the person is, where the pedestrian is, like in the image, just draw the bounding box and in the right position, and also to identify the class of the label in a very efficient way, like all in one box. Yeah. So unlike region-based method, that is like two-stage method. So YOLO will do it like in efficient way and will be embedded system friendly. Okay. So yeah, that's why YOLO can achieve high-speed inference, yeah, without compromising accuracy. So yeah, so I have done some work with YOLO version 8, okay? And I put YOLO version 8 in embedded system, and that is a developer board like Raspberry Pi, and its name is called RDK. RDK X5, that's a version of it. So RDK X5 is like a Raspberry Pi, but it has some extra ability. Actually, there is like MPU inside it. We call it like BPU. It's like the brain, but yeah, B is for brain. So BPU can do it like for model acceleration, AI acceleration, make your model inference like much faster. And end-to-end, RDK X5 can make YOLO version 8 N for the frame rate about like 220 FPS. And we can see a video about that. So let me start the video. Yeah, so yeah, this is like a situation that I was talking about. And when and I'll say it's actually very efficient, and the model is quantized into like 8-bit, like integer 8. So it's actually quantized and put into RTX5, and we can see that the accuracy loss is actually like not so obvious, and all of the different cars are detected very well. So, okay, so and the performance and is also very efficient. Okay, besides the object detection, we also have YOLO version 8N segmentation part. So this part is for instance segmentation. And I also deployed it into this RTX5. So what this does is to kind of take the mask of an image and try to explain like where the car is. So let's look at that by this video here. Is that working? Okay, yeah, I think the video doesn't show up. Okay, there you go. Okay, yeah. Right now you see that not only it shows the bounding boxes, but also the masks for different parts, and also different parts more than 150 FPS. So yeah, and again, this model, YOLO version 8N, is quantized in integer 8-bit. Yeah, integer 8-bit. So yeah, that's how it performs with instance segmentation in RTX5. So with those experiments, I think RDK series. So what is RDK? RDK stands for Robotics Developer Kit. So it is a series of different developer boards. So this series is a very good place to deploy your AI model and your own robot applications. So besides the computer vision we have seen, and it can also do like voice recognition, like voice interaction. And as you know, some of the tasks in voice recognition can be like ASR, KWS stands for like keyword spotting, and also like TTS. So ASR is like from your voice to some text, and TTS is like from some text to generate some voice from some text. Okay, and also in some reinforcement learning cases. So reinforcement learning is very useful in some control tasks. For example, if you want to make let's say a humanoid robot walk in some like let's say in a playground, or like in some mud environment, I think if you use reinforcement learning, the humanoid robot can walk very well in some complex environments. So yeah, and plus that for RTX5, this series we provide very good documentation. I follow through those documentation tutorials myself. So I think it's pretty clear. And for the code, they have sample code written in Python and C++. They have clean code with comments. It's very easy for me to follow along and to study. Okay, so besides everything we discussed, and they also provide like a model zoo. So model zoo is a place where like all different kinds of models live in. So again, they have like a computer vision model and also like NLP, natural language processing models, and voice recognition and reinforcement learning, okay? And those models are placed in this RDK model zoo. And if you have like a RDK board and you flush the image, the operating system into that SD card, and you plug the SD card into the board, and if you have the power on, you can start using it. And of course, you need to git clone this GitHub repository. After you finish the git clone, you can just start put the code into your RDK series, say X5, X3, or S100. Those are just like 3 different versions of the board, and they have like different memory size. So like 2 GB, 4 GB, or 8 GB. And coming soon, we're gonna have like a much bigger size of memory board called S100, and in S100 we're gonna have the memory size of 12 GB and 24 GB. Okay. So yeah, this one is like a voice demo, but obviously I don't think we have any voices here, so I'm just gonna explain along the way. So what's going on here?
Hey,
so
Snips.
First of all, the function is
请问你是谁？
KWS is keyword spotting. So I said like, hey Snips. Yeah, that's a keyword. I guess its name is Snips. So I said, hey Snips. So then it shows up in Chinese that, okay, now it's awakened. And I asked like, who are you? And in a very short time, it responds that, okay, my name is Robotics. I'm here waiting for you, okay? So then I do hey Snips again. I tried to awaken the Snips again, and I said,
向前走10米。
please go straight for 10 meters. Yeah, I believe that's what I said. Yeah, yeah. Please go straight for 10 meters. Okay, and the answer is that. Yeah, the thing is that this demo actually mimic a situation. This demo actually mimics a situation where you have like a real robot, a real humanoid robot, and the humanoid robot is placed in some like empty playground, and now you can like use voice to interact with this humanoid robot and to make him like move forward for like 10 meters or move left for 10 meters. So, and the interesting part here is that after ASR, the text is sent to the LLM, and the LLM actually has a memorization function. So it'll memorize like where it is like with your voice telling, it'll memorize where it is. So after like 10 meters, oops. Okay, let's go back. Yeah, I'll just keep explaining. So then what I said is that, hey, Snips, please move to the right for another 10 meters. Then I asked that humanoid robot, like, where are you right now? And because of the LLM, it'll remember that, okay, I have moved like 10 meters forward, and then now I moved like to the right for another 10 meters. So yeah, that would be very useful, and especially when you have like a real humanoid robot, you can interact with that. If you have like a real control API, then you can use the output of LLM to actually call for the real control API and to control the humanoid robot to move to a specific location that you want. All right. Yeah, so this is the voice demo. So again, let me explain the whole architecture here. So the first thing is that you have to do the KWS, that is keyword awakening. Okay, you have to make the things activated. Okay, and after the humanoid robot is activated, you can tell the robot to either move forward or move to the left or to the right. Yeah, and the robot will move to a specific location that you told him to do. So yeah, and it'll memorize the location from like the origin. So yeah, that's the voice demo we built in RDK X5. And the KWS ASR is running in the board, like offline. But for LLM, yeah, this one with memorization, we use the remote from the remote cloud. Yeah, because that would be like more efficient. So next, we are going to have, yeah, I'm going to introduce my company. I'm from Robotics. So Robotics is actually a company's name, and it also can be a development platform. So we try to create a new paradigm for intelligent robot development. So what's our mission and our vision? So our mission is to expand the intelligent capabilities of robot, and our vision is to lead the ecosystem of robotics era. Yeah, and as you can see, this is not only a board that has AI capabilities, but also it has some very nice ecosystem for robotics applications. And especially, I want to point out that if you are familiar with like robotics application, you may use ROS. ROS stands for like Robotics Operating System. It's not like a really operating system, but it is like a framework where it has very useful APIs you can, yeah, you can call and you can make the things more efficient. You can make the image transportation like from one node to another like more efficient. So yeah, and in RDK, the image, the ROS is already there. So yeah, and Robotics, our company, I'll say is a pioneer in robotics, in robotic computing. So Robotics is originated from a leading provider of ADAS and AD solutions for passenger vehicles, founded in 2015, with a mission to empower machines to make human life safer and better. Over the past 9 years, Robotics have evolved into a leading platform for intelligent robot development. We have transformed our vision to reality, bringing true intelligence to machines that seamlessly integrate into everyday life. Yeah, so that is our mission. We want to empower we want to empower the humanoid robot and also the four-leg dog, or some like our Origin Man, Origin Bot, empower them with intelligence using AI and some very reflective, yeah, some very intelligent, let's say, the control APIs. So yeah, this is our board working with like different corporation companies, and for those corporation companies, they have like a vacuum machine, yeah, like the one we saw it here, and there is also like a floor cleaning machine, and also like we saw and we see that we have like a robot arm and also like a four-leg robot. So yeah, those are our corporation companies, and they all use our RDK series. Now, not only RDK X5, but also RDK X3 and S100. Yeah, they use the RDK board to empower their robot with intelligence. Yeah, and besides the business corporation companies, we also serve like 50,000 developers. And those developers can use our sample code to learn how to build an AI application and a robotic application. And we also support like more than 200 startups. Yeah, and those startups, they want to sell their robot. They need like a brand, and they are going to choose our RDK X5 for that. OK, so yeah, thanks. Yeah, this is my presentation. Yeah, hopefully Yeah, you'll see like the new paradigm for the robotics application, like to use RDK series.